Welcome to the walkthrough for Assignment 3A. The purpose of this assignment is to deepen your experience using Java 8 functional programming features and their integration with the Java fork join pool. In particular, in this assignment, you'll develop an app that uses the Java fork join pool framework to obtain, store, and transform images. Like the earlier assignments, the code you write here will have a GUI and will run as an Android app. Please use this GUI along with the JUnit test discussed below to help test and debug your solution. The following resources may be helpful in completing this assignment. Videos that present a detailed overview of the fork join framework are available in videos 12 through 18 in one of my YouTube playlists. There's also good overviews of the Java fork join pool that appear at these links. Naturally, we'll cover all this material in class, which will be available in my YouTube CS891 playlist. Before you complete your initial submission of Assignment 3A, you'll need to do the following. Complete your implementation of Assignment 2C, taking into account my review comments. In particular, it's important that your unsynchronized array and potentially your array collector implementations work properly, since they'll be used as the basis for the app in this assignment. As always, please come to office hours if you have any remaining questions about your Assignment 2C solution. The image crawler app is packaged as a project using the latest version of Android Studio. As always, this app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purposes of Assignment 3A, however, you only need to be aware of the following three directories. The crawlers directory, which contains the skeletons you'll need to fill in, as we describe in a moment. The test directory, which is a set of JUnit tests that exercise the features under test and can be used to evaluate whether you've correctly satisfied this assignment's requirements. And the Assignment 2C test, which is an Android Studio instrumentation test that runs your app automatically. As always, you'll need to use the provided Android Studio project. I assume at this point you know how that works. In this part of the assignment, you'll complete the implementation of an image crawler class in the crawler's forkjoincrawler1.java file. This file obtains, stores, and transforms images. This class uses the Java fork join pool framework to perform an image crawl starting from a root URI. Depending on the parameters used to run the tests, images from the HTML page reachable from the root URL are either downloaded from a root website or read from the local file system, and the results are stored in files after they're transformed. The bulk of the code for the app is provided in the skeletons. In fact, as always, there's a complete solution using Java 7 features provided in the crawler's sequential loops crawler.java file. You'll focus on converting this Java 7 based class to the fork join crawler 1 class that uses the Java fork join framework. Feel free to use Java functional programming features such as lambda expressions and method references and sequential streams, but not parallel streams in your fork join crawler 1.java implementation. The skeleton code for this assignment is available in my GitHub account. Naturally, you should be able to pull this into your GitLab account, read it carefully, and complete the to-do markers. There's also JUnit tests in the test image crawler folder, which are provided to increase our confidence that your implementation is working as expected. You need to learn how to use the Android Studio GUI to run the JUnit tests locally on your computer, which you should have no problem with at this point. And as always, testing only demonstrates the presence of bugs, not their absence. So don't rely solely on the JUnit test to detect problems in your code. Naturally, I'll also be reviewing your code and giving you suggestions for improvement. The fork join pool framework in Assignment 3A is designed to give you experience programming directly to the Java fork join pool framework APIs. Although this framework is powerful, you'll need to manually keep track of various details. In contrast, these details are handled automatically by the Java Parallel Streams framework we did in Assignment 2. Therefore, please start the assignment soon and ask questions in class, office hours, and on the discussion forums. The app, image crawler skeletons, and JUnit tests are extensive, though you don't need to understand them all to complete your solution. Now that we've discussed the assignment specifications, let's take a look at the skeletons, which as always are under the image crawler Java package. If you take a look down here at utils, you'll need to make sure that you implement the unsynchronized array implementation from before. You also may need to use the array collector depending on how you do the fork join pool implementation for Assignment 3C. Let's go take a look over at crawlers. As you can see, we've got the earlier implementations you did for Assignment 1 and 2, so make sure you copy those in so you can have them and have them be tested as well, since the programs are cumulative. Let's go ahead and take a look at fork join crawler 1. So this is an implementation that's going to do an image crawl using the fork join framework, as the name implies. Let's go ahead and take a look at the to-do statements. So there's a number of factory methods that you'll need to implement, starting with one that will make the appropriate fork join array. And down here, you need to implement an array implementation. And of course, undergrad students need to replace this with the appropriate call. Whereas if you're doing this for the grad student version, then you can go ahead and use the array collector. So you can just leave it null. If you're doing the undergrad version, or if you decide as an undergrad to do the array collector version with sequential streams, you can just leave this null. Otherwise, you have to return the appropriate array. Let's look a little further. Here's perform crawl. That's provided for you. As you can see, that uses the common fork join pool, and it invokes this class called URL crawler task, which is created by a factor method called make URL crawler task. We'll see there's also a number of factor methods you need to fill in down here. You need to fill in the make perform transform task factor method. You need to fill in the make process image task factor method. And you also need to fill in the new URL crawler task factor method. And this makes the URL crawler task. These factor methods are necessary here because of the way that we do the mocking for the unit tests. So you have to make sure that you fill those in. They're very simple, as you might expect. Let's now go take a look at a number of the different classes you have to fill in. The way that things work with the fork join pool, as you'll discover when you watch the videos or just hear the lectures in class, is you end up implementing or extending something called recursive task. So as you can see here, URL crawler task extends recursive task, and then it provides various fields. It keeps track of the URI that's being crawled and the depth of the recursive processing. The constructor simply initializes those fields. And then we get to the actual logic part, and this is the compute method. And compute is the hook method defined on recursive task that you need to fill in. Let's see. So as you take a look here, you can see that it's got some of the code in it for you. So we first check to see if the depth is exceeding the max depth. If so, we return 0. We next go ahead and check to see if we've already seen this URI before. If so, we skip out and return 0. If not, it's automatically and atomically added, and we continue on. And then in the next part is really the code that you'll need to have to write. So in this part, the first thing we do is get the HTML page associated with the page URI. So that's provided for you. And then whether you're doing the grad version or the undergrad version, the logic diverges. The grad version, which undergrads are also welcome to do, simply uses a sequential stream. And what you do here is you'll go ahead and create a forks array with the appropriate fork join tasks objects that correspond to each of the types, either the image type or the page element type that's on the page. So down here, the first to do is to actually initialize the forks method. And now, in this case, if you're doing this in the grad version, you're going to create a Java sequential stream that will go ahead and get the image and page elements on the page, convert that to a stream, and then map each of these elements to the appropriate call to the appropriate type of task, either a process image task if it's an image, or if it's not an image, if it's a page, you'll use the URL crawler task. And of course, this is where you'll need to use your factor methods. You need to fork the results of those things, and then you can go ahead and map those elements. And what that will do, of course, is that'll end up creating a stream of these elements, and that stream will then be collected into the appropriate result, which is going to be this array of fork join tasks. And so once you've got this forks array of fork join tasks, then you're going to go ahead and do the next piece of the logic here, which is basically replacing the return 0 with the conversion that will join all the results in the forks array and sum them. So if you use Java streams, it's fairly straightforward to do this using various stream methods like map or map to int and so on. So I'll let you figure out the details, but that's the way you would do things if you're doing the so-called grad version. If you're doing the undergrad version, then it's basically the same logic, except rather than using a stream, you'll use a for each loop. So the first thing to do, of course, is you'll make the appropriate forks array, which is this array of fork join tasks, using the factor method that we talked about earlier. And then in this case, you go through every element in the range of page elements on that page. And if it's going to be an image, you do one thing. If it's going to be a page, then you do something else. And again, here you'll be using those factor methods to make the appropriate process image task or make the appropriate URL crawler task, fork those tasks, and then add them to the forks array. Then down at the bottom of this code for the undergrad version, you'll go ahead and have a for each loop that will iterate through the array of results and go ahead and join everything together. So this is a little bit more verbose than using the sequential stream, but it's more or less the same idea, just using it for each loop instead of using a stream. The next class that you'll need to implement is called process image task. This again is a recursive task, so it extends recursive task. And once again, it keeps track of the URI for the image to process, which is set in the constructor. As before, the heavy lifting in this method is done in the compute hook method, which is inherited from recursive task. As you can see here, it goes ahead and gets the image, and then depending on whether or not you're doing the grad version or the undergrad version, you'll either have a stream or a loop. If you do the grad version, then as before, you'll go ahead and apply all the transforms, and you can do that here by making a call to another factor method, the one that makes the transform task or the perform transform task, which is another class that we'll see. And in this particular case, you're going to transform the image concurrently. So of course, you're going to have to fork it, and then you'll collect those things into this forks array of fork join tasks. And then after that, you would go ahead and once again take the images that are in, or the results that are in the forks array, convert them into a stream, basically go ahead and join everything together, filter out any unsuccessful transform operations, and then keep a count of the final result. So that's what you do if you're doing the so-called grad version, which again, undergrads are free to do because it's pretty straightforward with streams. If you're doing the quote undergrad version, then in that particular case, you will need to call the appropriate factor method to make the fork join array. And then you have to have a loop where you'll go ahead and loop through the transforms and go ahead and perform the transform task on each transform for each transform, forking it and adding it to the forks array. And then after you get done forking everything, you will then go ahead and have another for each loop where you join everything together and keep track of the count. The third and final class that you'll fill in is called perform transform task, which again is a recursive task that you have to implement. Some of the fields, or one of the methods rather, the fields are provided for you. We have the image and the transform to apply. Those are set in the constructor. And the heavy lifting, of course, is done in the compute method. And this compute method will go ahead and basically attempt to create a new cache item for this transform. And it'll only apply the transform if the new cache item was actually created. In other words, if it wasn't already in the cache. So this logic should look very similar to what's in the Java 7 version. You just have to fill it in and put it in the context of the compute hook method, which is inherited from recursive task and used to provide the main entry point into perform transform task. So that's basically it. You're welcome to either do it with Java for each loops if you feel more comfortable with that at this point, or you can use the sequential stream. Whatever you do, don't use a parallel stream. That will be completely overkill because the fork join framework will be doing all of the concurrency for you. So that's the end of the walkthrough for the skeletons. Now that we've examined the specifications and the skeletons, let's show how to run the unit tests. If you click on the tests folder and then right-click on the EDU Vanderbilt image crawler tests and run them, the tests will build and start to run. As you can see, there's an extensive number of tests because we're testing all the different implementations so far. So it's important to make sure that everything you've done work properly. As you can see here, all my tests passed and everything looks green. So that's what you should get when you run the tests on your program as well. Naturally, if you have any problems, please feel free to come to class or post questions on the Piazza forum or come to office hours.